This video explains what are acids and bases, and you will learn about naming inorganic acids and bases, how to write dissociation equations, and properties and chemical reactions of acids and bases. Acids are a group of compounds that dissociate in aqueous solution to produce H ions, or they are also called a proton. Bases are a group of compounds that dissociate in aqueous solution to produce OH ions or hydroxide ions. Let us first understand naming of acids. Acids can be broadly classified into organic and inorganic acids. Organic acids are compounds mainly made up of carbon, hydrogen, and oxygen, and some other elements. For example, CH3COOH is commonly called acetic acid. We'll discuss naming of organic acids in the next module. Inorganic acids can be broadly classified into binary acids and oxo acids. For naming inorganic acids, the type of anion determines the name, and the suffix of the anion is changed. So what does that mean? Binary acids have two parts, the proton and a simple anion like a halogen or a cyanide ion. The proton is named as hydro, and along with that we name the anion, which could be a halogen or a cyanide ion, but the suffix of the anion is changed. For example, you have HCl, the anion here is chloride, and the suffix IDE is changed to IC. So it's now called hydrochloric acid. HBr, the anion is bromide, and the suffix IDE is changed to IC, so it's hydrobromic acid. Similarly, you have hydrogen fluoride or hydrofluoric acid, or you have HI, which is hydroiodic acid, and HCN, which is hydrocyanic acid. So this is how we name binary acids. Then we have oxo acids. They have hydrogen, oxygen, and some other elements such as sulfur, phosphorus, or nitrogen. They are named after the oxo anion produced. For example, nitrogen forms two acids, HNO3 and HNO2. The oxo anion is nitrate and nitrite. The ATE is changed to IC, and it's called nitric acid, and it has more number of oxygen, that is why we use IC. While for HNO2 it's nitrous acid, and the OUS is because it has less oxygen. Sulfur forms two acids, H2SO4 and H2SO3. The oxo anions are sulfate and sulfite, and the suffix is changed to IC and OUS, so it's sulfuric acid and sulfurous acid. Carbon forms only one oxo acid, and the oxo anion is carbonate, and it is named carbonic acid. An interesting case is of chlorine that forms four different acids. If there are several oxo anions, then we use hypo and per as prefix. So the four acids and their oxo anions are HClO, which is hypochlorite ion, HClO2 is chlorite ion, HClO3 is chlorate, and HClO4 has perchlorate. And they are named as hypochlorous acid, chlorous acid, chloric, and perchloric acid. So this is how we name acids. For naming of inorganic bases, there are two types. You have organic bases, which are amines, and we'll discuss more about them in the next module. Inorganic bases can be of three types. One is metal hydroxides. For example, sodium hydroxide, potassium hydroxide, calcium and barium hydroxide. Ammonia is also a base, even though it does not have hydroxide in it. Some metal oxides show basic properties, not all. For example, magnesium oxide and potassium oxide. Now let us see how to write dissociation equations. As mentioned earlier, acids dissociate in water to produce H ions and bases dissociate in water to produce OH ions. We can represent dissociation of acids in two ways. For example, hydrochloric acid dissociates in water to produce one proton and one chloride ion. It can also be represented in another way because the proton forms a dative bond with water molecules to form a hydronium ion. So it can also be shown as hydrochloric acid combining with water to form hydronium ion and chloride ion. In most of the equations in the workbook, we'll use the first equation with just a proton, though both equations are correct. Note that hydrochloric acid dissociates to produce one proton, therefore it's called a monoprotic acid. Hydrochloric acid completely dissociates in solution, and therefore we use a single arrow, and it says that it's a strong acid. We'll discuss about strong and weak acids in later videos and workbooks. Sulfuric acid is an example of a polyprotic acid because it has more than one ionizable proton. Polyprotic acids ionize in steps, and it is represented by these two equations for sulfuric acid. In the first step, sulfuric acid dissociates to form a proton and hydrogen sulfate ion, and the hydrogen sulfate further dissociates to form a proton and sulfate ion. If you add up the two equations, you'll see that one molecule of sulfuric acid generates two protons, and therefore it's called a diprotic acid. Another example of a polyprotic acid is phosphoric acid. Phosphoric acid dissociates in three steps. In the first step, it generates a proton and a dihydrogen phosphate ion. The dihydrogen phosphate ion then dissociates to form a proton and hydrogen phosphate ion, and in the third step, the hydrogen phosphate dissociates to form a proton and phosphate ion. One molecule of phosphoric acid produces three protons, and therefore it's called a triprotic acid. For bases, the dissociation of metal hydroxide can be represented by the equation where a metal ion and hydroxide ion is produced. Ammonia does not have hydroxide ion, but it reacts with water to generate OH ions. You'll note that there is a double arrow in this equation, which means ammonia generates very few hydroxide ions and quickly reaches a state of equilibrium. Metal oxides react with water to form hydroxides, and the hydroxide then dissociates to form metal ion and hydroxide ion. Let us look at properties of acids and bases. The general property of acids is that they are sour in taste. They dissociate into ions in solution, so they are good conductors of electricity. The presence of protons changes the color of a group of chemicals called indicators. The general property of bases is that they have a soapy touch. They are bitter in taste. Bases dissociate in water to produce metal ions and hydroxide ions, and therefore they are also good conductors of electricity. The presence of hydroxide ions in solution also changes the color of a group of chemicals, which are called indicators. Indicators are chemicals that bind either with H ions or OH ions and change color, and therefore they show different colors in acidic and basic solution. For example, phenolphthalein, it's colorless in acid, but in the presence of OH ions in a base, it turns pink. Litmus is another indicator. You have a blue litmus and red litmus. Now, if you put blue litmus in acid, it will turn red. Or if you put red litmus in a base, it will turn blue. But if you put blue litmus in a base, it won't change color. And if you put red litmus in acid, it will not change color. Here are some chemical reactions of acids and bases. One is neutralization reaction. Acids react with base to form salt and water. An acid has a proton and the anion, and you have a base with a hydroxide ion and a metal ion. The proton reacts with the hydroxide ion to form water, and the metal ion reacts with the anion to form salt. For example, sulfuric acid reacts with potassium hydroxide. The proton and hydroxide form water, and the potassium and sulfate ion form the salt potassium sulfate. Metals also react with acids, not all metals, some do, to form salt, and hydrogen gas is released. Acids react with metal carbonates such as sodium carbonate or magnesium carbonates to form salt, water, and carbon dioxide. And they also react with metal hydrogen carbonates to form salt, water, and carbon dioxide. Acids react with some metal oxides, not all of them, to form salt and water. These are basic oxides. And lastly, we have amphoteric oxides. These are metal oxides that undergo chemical reaction where they can act as an acid or a base. Examples of amphoteric oxides are aluminum oxide and oxides of zinc, tin, and lead. For example, in this reaction, aluminum oxide acts as a base and reacts with an acid to form salt and water. And here, aluminum oxide reacts with sodium hydroxide, and therefore it acts as an acid to form salt. So in the workbook, there are questions based on all these concepts. So good luck and enjoy.